show that mu equals xy squared is an integrating factor for something dx plus dy equals 0. So integrating factor means this is in the form of m dx plus n dy equals 0. Okay, this is not an exact that we can check, but if we multiply by this xy squared, then this becomes exact. That means this is an integrating factor. We can check, let's check if this is an exact. Okay, so m is 2y minus 6x. M is a function of xy, is 2y minus 6x. Okay, and if we find partial derivative of m with respect to y, this is 2 minus 0, just 2, and n is given as 3x minus 4x squared y to the negative 1. Now let's find partial with respect to x. 3x is 3 minus y to the negative 1 is like constant, 2 times 4, 8x, y to the negative 1. Clearly these two are not the same, so not exact. Okay, otherwise this ODE could be solved. If this were an exact, then we didn't have to have an integrating factor. Okay, this is just to check. Now let's multiply this ODE by this function xy squared. If this ODE becomes an exact after we multiply by xy squared, that means by definition this is an integrating factor. Okay, so let me put this way: multiply the ODE by xy squared. We get, so multiply means there are two terms, we multiply here and here. Xy squared 2y, that is now 2x y cubed minus 6x squared y squared dx plus 3x squared y squared minus here 4x squared x 4x cubed y to the negative 1 y squared 2 minus 1 just 1 y 1, we don't have to write that many dy equals 0. Let's see if this is an exact. Okay, so we do the same type of work, but now our m is updated. Okay, our m is different. This is our m as a function of xy, and this is our n as a function of xy. Okay, so m, partial derivative of m with respect to y is, with respect to y means y cubed 3y squared, 3 times 2, 6x y squared minus, with respect to y, right? So y squared means 2y, 2 times 6, 12 x squared y. Now for n, we find partial with respect to x. So x squared 2x, so 3 times 2, 6x y squared minus, we are doing with respect to x, so here is x cubed, that's the 3x squared, 3 times 4, 12 x squared, and we have y. Oh, they are same. That means this ODE we can label. I'm just saying dot dot means this is star. Same, that implies the ODE star is an exact ODE. That means the function that we multiplied by xy squared is indeed an integrating factor because that made the ODE an exact. Okay, thus the function, okay, which is xy squared, or that was given mu by the way, is an integrating factor. Now we need to solve this equation, this ODE star that I named star, we need to solve. And we know that when we have an exact ODE, then we can find a function f. Okay, and so since, let me write that, since the ODE star means this is an exact, what happens is we can find a function, let's say uppercase f, as a function of xy, such that when we find the partial derivative of this with respect to x, we get m back, okay, which is 2m is 2xy cubed minus 6x squared y squared. Let me name this equation just for me, I'm writing 1. And at the same time, this unknown function to be determined, partial derivative of that with respect to y is n. n is 3x squared y squared minus 4x cubed y. Let me put equation 2. I'm just naming as equation 2. And we know that the solution of this ODE is the function, to be determined, that function equals some constant. Okay, this will be our solution. That solution is given, in fact, implicitly. Okay, so we have partial derivative of f with respect to x, partial derivative of f with respect to y. But what is f itself? So we can integrate 1 with respect to x or integrate 2 with respect to y, same thing. Let's integrate 1 with respect to x. So integrate 1 with respect to x. That means this becomes just a function, as a function of xy, by the way. We are just lazy not to write this one, but this function is indeed a function of xy. Let's integrate with respect to x. Y cubed remains as a constant. So antiderivative of 2x is x squared y cubed. Minus, we are doing with respect to x, right? 6 times y squared is constant, 6 is constant because we are doing with respect to x. X squared is x3 over 3. So 3 goes 6 2 times. So 2x cubed y squared plus, when we integrate, we get a constant. It could be a pure constant, or in this context, even function of y is a constant. So it could be a function of y. So we just write hy. Hy could be a pure constant, or it could be a function of y. So let me put this equation. This will be, as soon as we find the value of h, this function equals constant is the solution. Let me name this one just for future reference, number 3. Now equation 2 is, this equation is fy. So we have f here. Let's find the partial derivative of this f with respect to y so that we can compare, and hopefully we'll get the value of h. So find the partial derivative of this with respect to, so from 3, what is fy? Partial derivative of f with respect to y. So x squared bf like constant, so 3y squared. So 3x squared y squared minus 2x cubed is constant. y square means 2y, so 2 times 2, 4x cubed y, plus we are finding derivative with respect to y, partial. So, but this is a pure function of y, it could be constant, so it's just the derivative s prime. When we have a function of single variable, the partial derivative will be same as the regular derivative, okay, because only one function. And I'm going to call this as equation 4. Now let's compare 2 and 4, because we are trying to get the value of h and the solution is given from 3. So compare 2 and 4. Fy, left hand sides are same, and that's by design, because we found the partial of f with respect to y. Right hand side 3x squared y squared, same thing, minus 4x cubed y, same thing, and there is nothing but we got h prime y. Okay, the left hand sides are same, fy means these two right hand sides should be the same, but they are equal, that means this must be equal to 0. Okay, there is nothing left. Okay, that means h prime of y equals 0. Okay, now we can find h, integrate both sides, then h is a constant, or it can be taken just integrate both sides, so h is a function of y is just a 0 or constant. Okay, c or k, doesn't matter. Now we plug this back here in equation 3 and we get the solution. Okay, so we can write thus the solution of the ODE that is now implicitly given. This constant, the function equals constant here, like this one, but this constant will be just absorbed when we move to the other side. So okay, let me write fxy equals some constant, which is what, x cubed y, sorry, this is x squared, not cubed. Okay, x squared, okay, 3, okay, x squared y cubed minus 2x cubed y squared plus h is constant, I mean k, but then when we move to the other side is another constant, arbitrary constant, so that when you subtract it's not 0, it would be another constant, so I'm writing c again. Okay, this is the solution given implicitly, final.